Welcome friends. This video lecture is just the continuation of the permutation. We know what is permutation. Now it is the restricted permutation. That means few restrictions are imposed in the situation. That time what should be the formulas will be there in the permutation that we will discuss in this lecture. So suppose r number of objects are to be taken from total n different objects given. Among these R objects, M particular objects are never included. If it is so, then the formula is N minus M PR. For example, suppose 1, 2, 3, 4 and 5 fruits are given. Among these 5 fruits, orange and lychee will never be included or taken. So, from the remaining 3 fruits, we are supposed to take any 2. So if it is so the remaining 2 means here the 5 minus 2, so the remaining are the 3 number of fruits. With that, we are supposed to choose any 2. So this is the total number of permutation, which is 6. Here, in the first choice, we suppose take mango, and the second choice, we suppose take the apple. So that in the second set, we can choose first apple, then mango. Then two type of combinations are there. Then mango, banana, banana, mango, apple, banana, banana, apple. So these are the total 6 different choices, and this is the total number of permutations which we can do in the situation. Next situation is the same n number of total objects are there, and r objects are to be chosen. Among these r objects, n particular objects are always present. In the previous one, some objects are always absent, and here the some objects are always present. That time what the formula? This is n minus m p r minus m into r p m. So what we will do? When some objects are always present, then what we will do here? Suppose the previous example, 5 total different fruits are there, and let banana is always present there. So that remaining number of fruits are 5 minus of 1, then p, and our total number of choices are suppose same 3. So out of 3, banana is always there. That's why out of 3, banana is always there. So the remaining 2 things we are supposed to select from the remaining 4 fruits. Now here the R is 3 and P and M is 1. That means banana is always selected, and that can be chosen in a row. There are total 3 positions, no? 1, 2 and 3. So banana can be chosen at the first place or second place or third place. For this arrangement, this permutation is there. So this is when M particular objects are always present. Now the next situation is M particular objects are placed in M given positions in a given order is n minus m p r minus m. Here this term is absent. What does it mean? Here it is given that the places are fixed for the chosen particular element. So m particular objects are placed in m given positions. So for example, suppose this one is the set where total 6 numbers are there. Among these 6 numbers, suppose 2 and 3. These 2 numbers are fixed, and these 2 numbers are fixed in the positions also. So this is the fixed thing. So the remaining 2, our total choice is 4. Out of these 6, 2 is fixed. So the remaining positions are 2. So out of these 4, any 2 we can select and we can set up. So according to the formula, it is 6 minus 2p. Here 4 minus 2. This is the total number of permutation, which is 4p2 or 4 factorial divided by 2 factorial. That is 4, 3. That is 12. Next is M particular objects are placed in M given positions in any order. Previously the orders are fixed. Now here no orders are there. That means 2 places may be restricted for 2 particular elements, but they can exchange their places. So again, if we consider the same example and suppose 2 and 3 are the fixed, so that time if we place 2 here and 3 here, 2 here and 3 here, then this 2 and 3 can exchange among themselves. According to these situations, the formula is m factorial into n minus mp r minus m. Next situation is m particular objects occur together. Its formula is r minus m plus 1 into n minus m p r minus m. Suppose the same example we have chosen, and here 2 and 3 are the objects which are always coming together. 2 and 3 are always coming together means either this one is 2 and this one is 3, or this one is 2, this one is 3, or this one is 2, this one is 3. So these are the 3 different positions. So the remaining 2 can be combined is the n minus m p r minus m, and here this one is r minus m plus 1. That means here total out of 4 situations, out of 4 positions, we have the 3 different choices to place the fixed elements. So this is the formula. One more thing is the circular permutation. That one is very important. An arrangement of objects around a circle is called the circular permutation. So that its formula is n minus 1 factorial. If it is not a circular permutation, a linear permutation is there, then if n objects are there and all these objects if you want to arrange, then its formula is just n factorial. But if it is circular, then it is n minus 1 factorial. That is because suppose this is the 8 objects are given in a circular manner. Now if we fix this object, after fixing this one, we can arrange the remaining 7 objects. So there are all different possible combinations by n factorial ways. That means here total n. If we fix any one, then the remaining is n minus 1. Then we can arrange the remaining n minus 1 in n minus 1 factorial way. Now this arrangement may be of 2 types. One is the clockwise and another one is the anti-clockwise. If clockwise and anti-clockwise both are same, then it doesn't matter. Then the total thing is, if this is same in clockwise and anti-clockwise, then what happens? Clockwise and anti-clockwise for we have the same combinations, and that's why our formula that time is half of n minus 1 factorial. Because if we take the clockwise, suppose this is one of the arrangement, and if we just exchange 2 to 8, then 3 to 7 and 4 to 6, then it is definitely a different arrangement but in the same sequence. That's why if clockwise and anti-clockwise arrangements, it doesn't matter, then its formula is this one. For example, if we consider the beats of a chain is there where all beats are same. That time the circular, that is clockwise and anti-clockwise, doesn't matter. These are the few important aspects of the permutations. Now next chapter, it is the combination. Thank you.